Oh, big time. Yeah.
Okay.
We're trying to get it. I think it's pretty serious. It's
Like,
pretty,
what kind
pretty fucking shitty.
What kind of trailer is it?
Like, is a trailer good enough to replace Josh once he uses that? Like, it's the new child.
Oh, I'm sorry, but yeah, 100%. We should be going with Easter, so we're trying to get it all up and running before we leave. And then he and Mum are going away for like, I don't know, 10 weeks later in the year. Got a few
At
guys.
Josh's
Josh doesn't know
house.
what's happening, so
I will bring alcohol.
please don't. To be fair, Dad, the thing happening is the shelf is about to break because every time someone finishes, they buy him a bottle of something and he doesn't drink it quick enough. He just
Most of my bottles don't actually make it home.
Yeah,
Depending on how far it is to the bus. What do you think? Be half gone by the bus.
I know, I'm sure he's
And
concerned.
there's usually on the bus who becomes my friend. He doesn't want to be, but instantly he's my friend. Bestie buddies ever. And then there's a guy in a uniform that turns up, and then he doesn't want to drink for some reason. I don't know why. Party pooper. Let's do this then. So, today we're going to look at. We're going to look at data table. So, the problem I've given you as your assignment is the reason I learned data table. So, because I was asked to do the actual problem in assignment 3 was a problem I was asked to do by ACAD, and I tried to do it in the plier, and I broke my system numerous times. So I thought, and someone said go and learn data table. So I went and learned data table. I don't use data table most of the time, except for when I get really big data. But for them few times, it is really, really useful. So what I've done in this workshop is I've created myself, and hence for you, basically a series of slides that goes, here's how you would do it in the plier, here's how you now do it in data table. And I would generally say, just keep this, and in the future, if you get data that's too big to do with data table, instantly too big to do it in dplyr, just quickly open up this. It's really good for that. And it's not too bad. So what you'll need for this is you'll need the usual things: tidyverse, forecast, read Excel, data table, and micro benchmark. So the first thing you have this really nice command called fread. There's also an fwrite, which will read in CSVs, and it will read them in very, very quickly. If you try and read this in using read_CSV, even though that's optimized, you'll find that it's terrible. Luckily for you, this data, the flights 14, is not that big. But the real data you're going to do with DNA methylation will take, I think, 3 to 4 minutes to read in if you use read_CSV, 20 seconds to read in if you use fread. So fread is the classic way. And what fread does when you do it is it automatically converts this into a data table. And when you actually now say, show me header data, it's slightly different. You'll notice, the only difference you'll notice at this point is you've got the 1:2 to give you row names. Also, with really big data sets, you'll find that when you type the name, it will give you the first 6 rows and automatically the last 6 rows. So it does a head and tail command, which is the first time you see it, it's like, what? And you can see there that basically when we look at class, and we'll discuss class a lot more when we do our next workshop on S3, they say this has 2 things. It's a data frame, so it inherits stuff from data frame, but also it's a data table. So it's quite a nice structure. And this is the basic form. Your commands are all done by using your bracket notation. So you would have your data table name and you would do brackets. You're not going to use migrate, you're not going to use filter, select, etc. It's all done via the brackets. And the brackets has 3 arguments. The first argument is all about selecting or filtering, asking where commands, or for ordering. The second one is all about selecting columns or updating columns, what we call mutate. And the last one is all about grouping. You don't always need all the columns, but if you want to do something in the second column in this, you'd have to go comma, then the command, then comma, and we'll see that. So we'll start with a filter. So what we're going to do in these, because this flight isn't big enough, we can actually use our dplyr and our data table at the same time to compare and contrast results. So the first one is going to be our standard filter in dplyr. So we take our flights, then we're going to filter where the origin is equal to JFK and the month is equal to, in this case, June. So we're going to find all the flights that set off from JFK in June in that data set.
Why have you got 6L?
6 is the integer, and L says this is absolutely an integer. So if you ever see commands, the L just says it's an integer. That's all.
Could you get away with 6 or?
I think you can with this. Most of the time you can. It's absolutely fine. But if you see every time you see a number and then an L, it's forcing it to be an integer, so it just takes that as memory. That's all. You don't need it most of the time. So how do we do the same thing in data table? Well, remember, the first bit in them arguments is going to be for filtering. So you can see here, I go flights, I get the square brackets, and I know that the first bit, so you can see I've got 2 commas. The first argument, I've done exactly the same thing. I said origin equals JFK and month equals 6L. Because you do this so commonly, they've got a shortcut. You can ignore these 2 commas if you want to. It just defaults that if you don't have them there, it assumes it's the first argument. Hello.
Hi.
So if you do them and have a look at your results, you should find that they are the same. So here's me just checking. Here's the head of the first filtered one and the head of the second filtered one. Okay. So as always, the question is, why would you bother? Because you've got your dplyr. Well, here's me just doing a quick benchmark on this. So you can see that if I use dplyr to do this very simple, remember the flights isn't large. The flights is only, I don't know how many rows it is, but it ain't many. But if you look here, to do your filter, takes a mean of 5.4 milliseconds. To do your data table command, it's half the time. Slightly less than half the time. And filter's actually not that hard a command to do. Once you start doing group by or mutate, that takes a lot more grunt to do. Okay. So everyone managed to do a filter? Anyone got any problems not getting the data or anything like that? All good? Cool. So, next thing you might want to do with that first, I keep calling it column, that first argument, we can filter on that first argument, we can also arrange. So, how do you do the arrange? Up here, to do the arrange, you give the column you want to arrange on, and here I'm saying arrange on origin in ascending order and destination in descending order. So remember, you can do multiple sorts in dplyr. So it will sort it in turn. It will first of all sort by the original one, and then it will stratify and sort by the second one, and you can have multiple sorts. And if we want to change, the natural one is to sort in ascending order. When that's levels, that will always be alphabetically, so that's the graphic order. If you want to flip the order, you use the DSC for descend command. How do you do that in your data table? Well, you use the order command, and again it will do an order. It will order ascending order of origin, and then you just, instead of writing des, you basically use a minus to change the order. So if you write it, it will do it in ascending order. If you put a minus, it does it in descending order. Remember, when you have multiple sorts, it sorts on the first column, and then it sorts on the second within that. So far we've got 2 things from dplyr. We've got the filter command, and we've got the arrange command. So next thing we should think about is select. So at the moment we can choose rows, and we can order rows. The next thing you might want to do is you might want to just select certain columns. So in dplyr, you would use a select command. Yes?
If you want to do both, filter then order.
We'll get to that. Yes. I do chaining of commands later on. So in this one, we're going to do select. So we're just going to grab the two columns, departure delay and arrival delay. So before you just use select. Remember, select's quite nice. It's got things like matches. You can actually select and say, select all columns that start with a particular word. There's various things built into select. What about with flights? Well, we know that it's the second argument that I need. So you need to let it know you want the second argument by putting this first comma. This comma is the one that you're going to keep forgetting and getting weird results. So it says takes the flights. The first comma says, I don't want you to order it. I don't want you to filter it. I'm happy with that. But what I want you to do is I want you to grab these two. Now the notation actually takes a list. You could actually have gone list, open brackets, the name of the first column, comma, the name of the second column. But to make it easier, data table has this shortcut notation here. If you go dot, commas, it's basically converting that automatically into a list structure for you. And you can just give whatever, and the order you give them is the order it will return. And you can see that this one is saying, go to flights. As I said, no filtering, no ordering. But when it comes here, select these columns. Okay, that's fine. But remember, select does more than that. Select, you can actually rename them as you select them. So, select and rename is the next thing you might do. So here's the deployer. We take flights, we're going to select, we're going to grab the departure delay and rename it depart, and the arrival delay and rename it arrival, and then I'm just grabbing the first 6 rows. So other than the fact that first of all you're going to get that comma, which as I said is the thing you're going to forget and the thing that will break it, because we're saying here there's no filtering, there's no ordering, there is going to be some selection. What's the selection going to be? The dot and the brackets say I'm going to create a list that will give you the things I want you to select. So depart delay and arrival delay, and if I just go depart equals and arrive equals, it will rename it at the same time. Cool. So let's do mutate. So mutate is where it really starts to come into its own for speed. Okay, so have a look at that. First of all, tell me what we're doing, and then tell me what's cool about what data table is doing. There's something subtle there that you might not realize. Go for it, Patrick.
Probably the colon for the second line.
Yeah, you've got the colon, so that's interesting to notice. There's a little gotcha there, you've got the colon, absolutely. So that lets you create and rename. But there's something more subtle there that's going on. Okay, let me ask you here. If I did this command, and then I came back and typed flights again, would that new column still be there? No, why not?
Because you haven't saved it.
Haven't saved it. What about with data table?
It's done in place.
Done it in place. So let's work through that. So first of all, let's remind ourselves what we're doing. We're saying take flights, then mutate. Mutate just means make a new column. So I'm going to get a new column called total delay, and I'm going to take the departure delay and the arrival delay and add them together. Fine. So let's look at flights. Flights, the square brackets. First of all, the comma that says you don't need to filter, you don't need to sort. Then it says what we're going to do. I'm going to take these two things and I'm going to add them together. Notice the colon equals. The colon equals is saying write me a new variable. And I did this. I went and typed that command, and then it didn't appear. Nothing happened. It just went click, and that was it. And then I went, shit, it's not worked. And then when I typed flights, it's actually added the column. But I haven't saved it. I haven't gone flights equals flights, comma. This is actually doing a function that's working by pass by reference. It's adding the column without actually you having to then save it again. which is what makes it so fast. It's actually doing the new column in place. And that ability to do that, that subtlety that you didn't even realize because you don't do it until you suddenly go, shit, when I add a new column, but remember this is now dangerous. If you mutate and add a new column, it will add it. Which you go, well that's okay. But if you make that new column a name of a column that's already there, you will wipe out your data. Because now in data table, it's doing it in place. It's not saying, here it is, do you want to save it? It's just saving it automatically. Makes it fast, but dangerous. So the next thing we often like to do is summarize. So we've got to the point we can get rows, we can get columns. We can rename stuff, we can now order, and we can add new columns. But often what we'd like to do is like to group by a variable and then get some summary statistics. So here's how we would do it in dplyr. So take flights, and I'm going to stratify by origin, destination, and month. So I'm saying, go and get every origin, every destination, and every month, and for that, I want you to spit out some summary statistics. What do I want? I want the mean arrival delay, and I want the mean departure delay. So I give a function, which takes in this case, one column, and this will rename it. And then I just give the top ones. So for here you can see that if you go from EWR to ALB, in January, the mean average delay is 35.4 minutes, and the mean departure delay is 42.5, etc. Okay? So how are we going to do that in data table? Well, we're going to use two. First we got the first comment, because we don't need to filter, we don't need to order. The second column says, right, remember, we're going to create ourselves some new stuff here. So what's it going to do? It's going to calculate the mean arrival delay and the mean departure delay, and it's going to give them these names. You put it in a list. We haven't got the grouping. The final argument gives us our grouping. So it uses the by command. So it's saying, do these calculations by this grouping. And here our grouping is origin, destination, month. It's optimized. So if you actually do this straight, you'll find it doesn't look like you're getting the same answer because it orders it slightly different. So I actually did this one just to make sure that the results look the same. Because if you do it without doing that, you just run the command, it does it and it spits it out, but it didn't give the first 6 rows were not the same with the 2 commands. They were the same result, but the ordering was slightly different, that's all. And it's to do with its representation and how it optimizes the code.
So here we're also adding columns, right? But
Yes.
we didn't do it with the create and assign. So could we have done the last thing this way as well?
You mean just do the dot mean equals this?
No, but not with the mean, but just like column A plus column B or whatever you did before.
You do need it when you create a new column. So this one you're just summarizing a column. With that one, the dot equal is saying create a new column.
Okay.
Now, whether you could do it without, you could have a try and see what it does.
Mm-hmm.
But all the stuff I read on it seemed to say that you do want to do it with the dot equals when you do the create a new column. Okay, so one of the classic summaries you want to do is just to count the number of rows. So there's actually, because you do it so often, it's a standard command in dplyr. There's a count command. So the count command, if you think about it, is saying group by origin destination, then summarize where n equals n bracket bracket. Because we do this so often, we just want to count the number of rows within groups. It's just a count command. So here, if I go flights, then count origin destination, it's going to count and say altogether there were 169 flights from EWR to ALB. Very useful count. Do it all the time. Again, there's a standard built in for your data table. It's the .n function. So this is say, take your flights, comma, so there's no filtering, no ordering. We're going to summarise by this .n, by, and here's my grouping. And then all I did is I made sure I ordered it so it was comparable to this, because you find that the order this returns and the order this returns are not the same in the way it's doing it. So to get to your question, one of the nice things about dplyr is what we call chaining. The ability to build up commands. So for example, in this one I'm saying take the flights, then I want you to filter on the carrier being equal to AA, American Airlines. Then I want you to group by the origin and destination. I want to summarise, so now I'm actually doing a count, showing you the count function, n equals n, and then I want to arrange by origin in ascending order and destination in descending order. So I've done a filter, then a group, then a summary, then an arrange. When you want to do it in data table, you basically add extra brackets. So this first one goes flights. I want you to filter on A. I want to have a summary.n by this. Then take this, and now you've got these extra brackets. Personally, I don't like this chaining because it'd be too easy to start missing the fact there's lots and lots of brackets. But that's the way they've built it in. I think I did discover you can break your order. Sorry, you can break your chaining over multiple lines. I think I found in the assignment a way of actually breaking it, so it made it a little bit easier to read.
Or couldn't you just do flights of that stuff and then the next line flights of the order bit and just doing 2 lines?
Yeah.
Make it more legible and easier.
Definitely could try it.
Shoot, works fine. Break up otherwise.
Oops. So now we're going to think about joining. The reason I've added this is we haven't really done a lot of how to merge 2 data frames together. So it's actually quite a nice thing to learn anyway, but it'd be particularly useful for your DNA one as well, because you came in 2 files. So what we've got here, we're going to use a built-in data set. So band members should be built into tidyverse. And this has your band name, first of all, is just a very simple tibble that has 3 people. It has Mick, John, and Paul. I'm not going to ask you who they are because I'll feel very, very old when you look blankly and say, who are the Stones and who are the Beatles? And then we've got information on the instruments they play. So John played guitar, Paul played bass, Keith played guitar. What does Mick play? He also plays an instrument. He's a really, really good harmonica player. He's like world-renowned harmonica player. He's actually seriously good. Unlike me, he was seriously bad. But. So, you have different ways you can join 2 data frames together. So when you're going to join 2 data frames together, first of all you have to say which columns you're going to join on. And also you have to think whether you want left join, right join, full join, inner join, anti-join, etc. Left join's the easier one to start with. So let's do left join. So what does left join do? It says take band members, so you've got the band members, and what it's going to do is it's going to have, basically, in this case, a row for each one in there, and it's going to say, when you come to this first one, what we're joining on, we're going to left join, it says here, we're going to join on name. So it goes, the name is Mick, it goes to the next one and goes, in here do I have a Mick? If I do, whatever information in that row that's contained with Mick, I will put here. There isn't any. Goes to the next one, John. Goes fine. I put all the information in John's thing, and then I go to this column, I find a John, and all that information I add to it. Obviously, ideally you want to have a unique key. Because if you had multiple Johns in this, it might be a bit confused. It might try and help you. it might go, right, you got John Beatles, I'll put that information in a row, and then I go, I found an extra John, I might add extra rows. Now left join shouldn't do that. Left join should just go, for every row in your left data frame, the first one, you keep that, and you have the same number of rows afterwards. Merging data frames is always dangerous, because when you merge them, it sometimes tries to help you. So if ever you are starting to merge data frames together, be very, very careful to go and check it's doing what you think it's doing. I find I nearly always use the left join, because then I can say, I know exactly the rows I want, just add extra information if it's contained in these other ones. You've already used the join because you used the anti-join when you did natural language processing. So in that case, he said, return all the rows, they're definitely not in this one. If you're not sure about this, if you go and look at the cheat sheet for it might be the data manipulation cheat sheet, it has a lot of pictures to illustrate what happens in different scenarios. There is a general merge command, which is the default underlying one built in R, which is what we all used to use. But again, as I said, merging is a thing that often breaks, and often does. You don't realize until you suddenly realize that you looked at your data and you had now 20 rows when you thought there was just one individual. Okay, so that's left join, all nice. Data table is a bit faffy, but fast. So, I've taken band members, and first of all, so I can do this, I set it up as a data table by coercing it. The same with band instruments. Now remember I said the way you match is you look at some sort of unique identifier. One of these columns needs to be what we call a key. And key should be unique. That is, each row has one key, and each key corresponds to one row. So here what I'm going to do is I'm going to go to the first one, and I'm going to set the key. Notice beforehand we didn't have to set keys to use data table, but some of these operations become a lot faster if you actually set the key. This comes back from SQL type commands where you actually have a key for everything. So this one I'm going to say that for the band members the key is the column name, and for the band instruments the key is the name. Now, unfortunately we use the word left join because this is a left join, even though now the one I want to actually work on is now on the right. This is what always confuses me. Just, to be honest, the way I do this now is I go, what would be the dplyr command, because I'm used to using left join, and then I just switch it around. And then I spend ages worrying that it's doing the wrong thing and checking. So here you're saying, you want your band instruments, and it's going to do a left join on band members. So you're going to have one row for every band member, and it's going to grab information from that and add it on. I hate merging data frames. I spent a lot of my time merging data frames and getting it horribly wrong. And I spent a lot of my time now just checking. And it can be really nasty. My Desert Island disk stuff I did, it took me approximately 3 days to join 3 data frames. By the time I actually got it to work. It was nasty. There was no unique key or anything, so I had to write a lot of code to do it. I took most of this from this vignette. The data table has a very nice vignette. If you go to the vignettes in data table, there's more, if you want to do more advanced stuff. But to me, the key place is you have a really, really big data table or data frame in a CSV, and you want to manipulate it, and dplyr is just not working. This is the fast way of doing it. This is the way that everyone does it. So the DNA methylation one that you've got, where we were looking at adjusting DNA methylation, taking into account modern DNA methylation, that was the thing that forced me to learn data table. So pretty well, you will never use this. You will, unfortunately, because you do ancient DNA. But at some point, if you get really big data, seriously, before you start going and learning SQL or using other things, just see if data table will do it for you. Any questions? Cool. I will make sure you have a link to the data. Unfortunately, the data is big, so I'd recommend you download it at work. because the DNA methylation data is 1.2 gig. That's it. Have a really good holiday. See you when you get back. Our next workshop will be on S3 object-oriented programming, and I'll teach you how to do that. Easy.